In this video, we're going to go over how to find the future value of one cash flow. So here's our problem. We're trying to find the future value in 5 years of $500 today if the interest rate is 10% per year, compounded semi-annually. So if we sketch this out on a timeline, time 0 is today. We're trying to find out how much the money will be worth in 5 years. And our interest rate is 10% per year, but compounded semi-annually. So we have $500 today, and the formula that's going to enable us to get from here to the end of 5 years is, of course, our main time value of money formula. And if we are dealing with semi-annual compounding, then we need to make sure that we use a semi-annual interest rate in the number of semi-annual periods. So in this case, future value is what we're trying to find. Our present value is $500. And if we're using a semi-annual interest rate, then if it's 10% per year, then we're going to put in 0.05, which is 5% per 6 months. And then I need the number of semi-annual periods. So if I have 5 years, then I have 2 periods per year because it's semi-annual, so I have 10 periods total. So if we do the math on that, and I will give you a moment to try that. So I recommend pausing the video at this juncture to actually work that out. So if you worked that out, you should have gotten a future value of $814.45. Now there's also another way that we could do this, and that is with the time value of money solver in your calculator. So in that case, we have various inputs. So for this scenario, recall that N, I, and payment always have to match the same time period. So if we're dealing with semi-annual compounding, then N needs to be the number of semi-annual periods. So we would have 5 times 2. The interest rate needs to be on a semi-annual basis. And since it is looking for it in percentage format, then you would do 10 divided by 2. Present value would be 500. Payment is if you have an annuity, which we do not have in this case. So payment would be 0, and then type applies to an annuity, so we don't need to worry about that. So if you put those inputs in your calculator, and then you go down to the future value line and hit alpha and enter if you're using the TI-83 Plus or a compatible calculator, then you should get the same value. So I'll give you a second to try that, so I recommend that you pause the video at this point to try that. Okay, so if you tried that with your calculator, you should have gotten a negative $814.45. And importantly, note that in this case, the negative sign doesn't have a whole lot of meaning to us. So recall the rules for using your calculator as far as signs are concerned. Any cash flow coming in needs to get a positive sign. Any cash flow going out should be getting a negative sign. And then you interpret the sign on the answer with a grain of salt. So in this case, we do have the same numerical answer, and we aren't really going to worry about the sign there. Now you should also consider trying this in Excel. Now if you try this in Excel, the formula you're going to want to use in Excel is equals FV, and then you'll need the rate, so you would want to put in 10% divided by 2, comma, and then the number of periods, which is going to be 10. or 5 times 2. Then you need to put in the payment, which is 0, because we do not have an annuity. Then you have the optional argument of a present value, which we do have, and that is 500. And then you can actually specify if an annuity is at the beginning or the end, which we don't need to worry about in this case because of the fact we don't actually have an annuity. That's an optional argument, so we can leave that blank. And if you work that out, you should get exactly the same answer as you got over here, again with a negative sign. So if you needed to do this in Excel with a positive sign, you would need to stick a negative sign over here in front of the FV in order to get the sign to work out the way that you wanted to. And that is how you find the future value of a single cash flow.